Good morning students, this is Sheba. Now we are going to discuss about the microprocessor and microcontrollers, UNIT-3, I/O interfacing. In previous sessions we have discussed about I/O interfacing and memory interfacing, 8255 parallel peripheral interface, 8251 USART, serial communication interface and ADC and DAC interface. Now we are going to see about the timer counter interface 8253/8254. This is the corresponding IC for timers or counters. You can see the pin diagram. It is a 24-pin dual-in package. It has 8 data pins, 2 clock pins, totally clock 0, clock 1, clock 2, 3 clock pins, 3 out pins and 3 gate pins are available, 2 address pins, 1 write pin, read pin, chip select and VCC and ground pins correspondingly. You can see the tabulation of these address pins corresponding to this. If you are giving 00, counter 0 is selected, 01 counter 1 is selected and 10 counter 2 is selected, 11 control word is selected. What is meant by this counter or timer? Yes, you can take a real-time example. For example, washing machine you can take. If you are running the washing machine for a certain duration, for example 30 minutes, you are setting the time. It will run automatically and after completion of that time the cloths will get dry and it will stop automatically. So what is the purpose of timer in this? Yes, it decreases the time for every work it completes. For example, if you are sitting at total 30 minutes, 10 minutes is allotted for rinsing purpose, 10 minutes is allotted for soaking purpose and 10 minutes is allotted for drying purpose. Means it will split out the time according to the work you have given and it will reduce the time whenever the work gets complete and it reaches 0. The counter will count how much time taken or how many times the clock has rotated or clock has initiated for controlling that particular operation or application you have given. So this is the real-time application of timers and counters. This is the corresponding block diagram of 825354 timer counters. You can see 6 blocks available: data bus buffer, read write logic, control word register and 3 counters. According to this, you can see the tabulation for corresponding 3 counters and control word, which I have clearly explained in the architecture diagram itself. This is the 8254 programming. You can see corresponding 0 to 7, 8 pins. First BCD pin selects when 1 and M0, M1, M2 selects the mode of the programming. And first 4th and 5th pin selects read or write control. Last 6th and 7th pin selects counters, either 0, 1, 2 or command word. You can see the operating modes of 8254. If you are selecting mode 0, an event counter enabled with G, that is gate, is the low count will be passed. And you can see in this diagram, gate is high will continue counting. If you are selecting mode 1, one shot mode, it is a one shot mode. Gate is high, output will be high. If you are selecting mode 2, counter generates a series of pulse 1 clock, pulse Y. The cycle is repeated until reprogrammed of G pin set to 0. If you select mode 3, it generates a continuous square wave with G set to 1. If count even, 50% duty cycle is set. Otherwise, out is high 1 cycle. If you are selecting mode 4, software triggered one shot mode. In the last, counting will be stopped and not repeated. If you are selecting, it is triggered with a count of 8. If you are selecting mode 5, hardware triggered one shot mode G controls similar to mode 1. It is triggered with count of 5. In the last count will be low. And this is the corresponding working of 8253, 8254 timers and counters. As I have mentioned in the earlier, this counter timers is implemented in many large scale home purpose as well as industrial applications like washing machine, microwave oven. You can set the time. For example, you can take in microwave oven, you are setting the time, you are counting for the reduction of time. For every reduction of time, the work gets completed. For example, if 30 minutes you are setting, it is reduced to 20 minutes, then 10 minutes of work has been completed. It is counted in the counter. Okay, how many set of work has been completed from the allotted entire work? And this is the major real-time application of the timers and counters. So that's all about the topic we have discussed. If you have any doubts in this, you can ask me and get the details. Thank you.